This is the first year algebra-based physics course. Topic 2 is one-dimensional kinematics. In section 2.11a, I'll be talking about how to set up and solve physics problems using the basic kinematic equations. Now, in this first video, 2.11a, I'll try to start with simpler problems, and then in the next video, 2.11b, I'll be continuing with some more difficult problems using, again, the basic kinematics equations. In order to get the full benefit from this video, you're going to want to download the New York State Physics reference tables from this website, NYSEDregents.org. You should keep an electronic copy on whatever device you're using, and you should also, if you have access to a printer, print out a hard copy. That means print it out on paper. The reference tables are 6 pages long. Page 6 is what we'll be mostly using in this video and the next video, and that page is called Mechanics. Now, in just a second, I'm going to show you the basic kinematic equations from the top left corner of the Mechanics page of the New York State Physics reference tables. Here they are. The first equation on the mechanics page, and the first equation we'll be looking at today, I like to call the velocity equation, or equation number 1. Now, there are 2 different ways to use the velocity equation. You can think of it, now first of all, the little line here means average, so this is average velocity equals, now you can think of it as average speed equals total distance over total time. Remember that to find the distance, you just add up all the places that you went, because we don't care about direction, because distance and speed are scalars. Now, to find average velocity, you would find the total displacement. You could just say displacement. You don't have to say total displacement. And divide that by the total time. Remember that displacement is the measure of straight from start to end. Now, there is one other equation that you should write down on your paper copy of the reference tables, or try to add it to your electronic copy, and that is the other equation for average velocity. Now, this equation is only valid when you know that the acceleration is constant. And the equation goes like this. Well, you're trying to find the average velocity. Well, how do you normally find an average? You add 2 things together, and then you divide by 2. So what you would do is add the initial velocity plus the final velocity, and then divide by 2. Write this equation down. It's not on the reference tables. The second basic kinematic equation is equation number 2, the acceleration equation. It's written on the reference tables, A equals delta V divided by the time. But since delta V is really V final minus V initial, you should never, ever, ever write down this version. It's basically useless. What you write down instead is that A is equal to V final minus V initial divided by T. Now, equation number 3 isn't really a brand new equation. It's just this equation, number 2, rearranged to solve for V final. So let's do that now. All right, so if A is equal to V final minus V initial over T, if we cross multiply, all right, multiply this times 1, we get V final minus V initial equals A times T, all right? And if we're trying to get V final by itself, we add V initial to both sides. That cancels, and we get this equation, V final equals V initial plus AT. So you see, on the reference tables, equation number 2 is the definition of acceleration, and equation number 3 really isn't another equation. It's just this equation rearranged to solve for the final velocity. So really, we won't call this a brand new equation at all. We'll just say that equation number 2 can be like this, and a couple of other versions when you solve for V initial or time. Finally, we have equation number 4, the displacement equation, displacement equals v initial t plus 1/2 at squared, obviously you would think of this equation when you're given time or you're trying to find time. There's time in this equation. Now, the v final squared equation, v final squared, that's equation number 5 on the New York State Physics reference tables. You would use this equation when you are not given time and you're not trying to find time, because there's no t in this equation anyway. Don't make the mistake that some students make. Which physical quantity are we talking about? Well, if you see the unit m, or meters, right, m is for meters, then you know that the physical quantity, right, is either a distance or a displacement. If you see only meters. Now, if you see meters per second, right, meters per second, then you know that you're looking at a speed or a velocity. Now, what happens is some students kind of see the meters and they kind of forget about that. Well, you can't, you got to read the whole unit, all right? You can't stop as soon as you see meters and say, oh, it's distance. No, no, no. If it's meters per second, that's a speed or a velocity. You have to read the whole unit. It's meters per second. Now, another common mistake would be to see meters per second squared, and you kind of forget about the squared. You kind of read meters per second. You say, oh, that's a velocity or it's a speed. No, 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 no. It's meters per second squared. You have to be very careful to read the whole phrase. This, meters per second squared, would be an acceleration. So please read the problems very, very carefully. Read the units very, very carefully, or there'll be mistakes. All right? Just read carefully. And you want to be aware of the difference between initial velocity, all right, that's either abbreviated VI or V naught, all right, the little zero, you say naught, all right, but either way, that means the initial velocity, the velocity at the beginning or the start, and final velocity, that's VF, all right, that would be the velocity at the end. So just be really careful. Which velocity are we talking about? Initial velocity, final velocity, average velocity. Just read carefully. Physical quantities you must infer. Sometimes you start a problem and you say to yourself, wait a second, I don't have enough numbers to solve this problem. Well, there are numbers that are hidden in the words in the problem. If the problem says starts from rest or drops from rest, you know that the initial velocity is 0. Right? Watch. If I drop this object, initially the velocity is 0, and then it starts to go faster and faster. But I didn't throw it down. I didn't give it an initial velocity like -3 meters per second. I just let it start from 0 and go faster and faster, naturally, down. So starts from rest, drops, or drops from rest means that the initial velocity is 0. So you've got yourself another number to work with. If the problem says that the object, for example, a car that has applied the brakes, that car comes to rest or stops, then you know that V final is 0 meters per second. You know that the velocity at the end is 0 meters per second. So again, you've got yourself another number. Now, any falling object falling near the Earth's surface, and near the Earth's surface, for our purposes, means anywhere within 50 miles of the ground, all right? We know that the acceleration with which the Earth accelerates objects downward, and we can call that g, we know that that's negative 9.81 meters per second square, or if you'd like to round that to one significant figure, it's negative 10 meters per second squared. So any object that is falling, the acceleration in the vertical direction is negative 9.81 or negative 10 meters per second squared. Again, if you find you're starting a problem and you don't have enough numbers, maybe you missed something in the reading that was actually a hint at a number that you need. To be given credit for a written problem, there's a lot that you actually have to put down on the paper. First of all, you have to list the givens with the correct units. You have to indicate what it is that you're trying to find, and you have to select the correct equation. Solve the equation for what you want to find. Whatever you're trying to find should be on the left side. If you're trying to find V final, the equation should read V final equals. Step 2, you plug in with the correct units, the correct numbers, and the correct units. Step 3, do your math carefully, get the correct answer with the correct unit, then round to the correct number of significant figures. If you're not sure about how many sig figs to round to, 3 is always a good bet. Okay, so remember that you have to write all this if it is a written question. If you just put the answer, you will get no credit. You have to show the math work step by step. A quick word about directions and the use of positive versus negative to signify directions of vectors. I will list all of the negative directions. That would be left, west, south, down, and clockwise in the givens. In other words, if a vector is stated as being south, I will put it as negative in the givens. But you don't bother putting negative into equations when there's only one direction. If everything's going in the same direction, the displacement, the velocity, the acceleration, all right, if there's only one direction and the object is not slowing down, then all the vectors will be in the same direction. So you don't have to put the negatives in the equation. Okay, so we'll make the first 4 examples very simple. Then maybe in the 5th example in the next video, we'll have one problem where there are 2 different directions. And you'll see when it's necessary to put negatives into the equation. Here we have the first problem. And all of the problems in the rest of this video and the next video involve the 5 basic kinematic equations on the reference tables, the first 5, and also the equation that I mentioned that you should write down that is not on the reference tables, and that would be V average equals V initial plus V final divided by 2. Keep that equation in mind. It's very handy. Now, what you're going to do for all of these practice problems, and you can also use this technique for any of my videos that you watch or any other physics videos or chemistry videos that you, math videos that you watch on the internet, is make a note of what time it is right now on the video when the problem is completely blank. After you watch me do the problem, what you want to do is come back to the point in the video where the problem is blank and try to do the problem completely on your own. You can pause the problem right here where you see the question, or maybe you see a little bit of how to get started, all right? But pause the video here and try to do the problem completely on your own. If you have any problems doing it completely on your own, then you probably want to watch me do it one more time so that you make sure you really can do this problem completely on your own. All right, so here we go, right? And use this technique. It's a very, very good technique. You have to practice doing a problem completely on your own to get good at physics. So let's start this problem. And the first thing you always do is you make a list of the givens. So here we go. Marvell runs a total displacement of 80 meters in 10 seconds in a straight line east. All right, so the displacement is 80.1 8.0 meters and 10 seconds east. So it's positive. We don't really have to worry about the sign too much if it's positive. All right, now keep in mind, do not read the whole problem and then start writing. As soon as you get to a number, all right, that you can put in the givens, you put that number down. You don't have to read the whole problem first. It doesn't make any sense. Get started. Start writing. Start doing the problem. All right? When you get into your second or third year of physics, maybe you read the whole problem first, and you'll know, right away what you want to start doing in terms of equations. But in the beginning, just start writing. Just get started. If his initial velocity was 2 meters per second east, so V initial, all right, 2.00 meters per second, that's east, so again, that's positive, all right? And he runs with constant acceleration. Okay, what is his final velocity? So we're trying to find his final velocity. So that's going to be meters per second, question mark, all right? And let's make a note of what we're trying to find. All right, we're trying to find his final velocity. This is what we're trying to find. All right? And also, what was his acceleration? So we're also trying to find his acceleration. So put a line. That would be meters per second squared. All right? And we're trying to find acceleration also. All right? Now, what I'm going to do, is to erase the problem so that I can shift the givens over here, and we have all this room on the board to work out the answers using several equations. So let's start figuring out the answers. What was his final velocity and what was Marvell's acceleration? Now, right away, I would say to you, when you see a total distance and a total time, right, a distance and a time like that, right away, I would calculate your average velocity, right? So here we go, all right? Average velocity equals total distance over total time. All right, I would always do that right away. All right, so we've got here, right, 80 meters divided by 10 seconds. So your average velocity is 8.00 meters per second. Now, we'll be working with 3 significant figures for this entire video and the next video. Everything will be to 3 significant figures. All right, so here we go. Except, I'm sorry, I will, if something is falling, I'm going to cheat a little bit, and I'm going to use 10.0 meters per second squared. All right, just to make it a little bit simpler. But everything else will be to 3 significant figures. All right, so we've got our average velocity. Now, what's nice about that is we're trying to find V final. And we've got that equation that I told you about where V average, all right, so this is the first equation that I used, all right. We've got that equation where V average is equal to V initial plus V final divided by 2. Well, we've got V initial, we've got V average, so we can find V final. All right, let's cross multiply. All right. Put this over 1. All right. V initial plus V final equals 2 times V average. All right. And actually, if we're going to number the equations, let's do it in blue so we don't have too many numbers all over the place. This was the first equation that we used. This is the second equation that we're using. Okay. So now, we're trying to find V final. So I'm going to subtract V initial from both sides. The equation we'll be using, V final equals 2V average minus V initial. All right, so let's bring that equation up here and use it. All right, V final equals 2V average minus V initial. We know that V average is 8 meters per second. So 2 times 8 meters per second, all right, minus, V initial was 2 meters per second, all right, 2 meters per second. All right, so what we've got here for V final, 16 minus 2, all right, V final is 14 meters per second. All right, so there we go. That's your answer here. V final, all right, V final is 14 meters per second. We've got that now. All right, now, the next thing we were asked to do was to find the acceleration. The second equation on the mechanics page of the reference tables. All right, so this is the third equation that we're using for this problem. And that equation would be A equals V final minus V initial over T. All right, so V final was 14 meters per second. V initial was 2 meters per second. The time was 10 seconds. Here we go, plugging in. So A is equal to 14 meters per second minus 2 meters per second. That's going to be 12 on top divided by 10 seconds. 12 divided by 10 is going to give us an acceleration of 1.20 meters per second squared. All right, so that answer goes here. All right, 1.2 meters per second squared. Technically, we have V average also. All right, we knew that V average was 8, so we can put that here. We weren't asked for V average, but we used it to get to other answers. All right, 1.20 meters per second squared. All right, so we've got all of our answers. We were asked to find V final. We were asked to find the acceleration. We did. All right, and again, what you want to do now is go back to a point where the problem number 1 was blank and try to do the whole thing on your own. All right, if you find you can't get the whole thing done on your own or you get some wrong answers, then watch how to do the problem one more time. Once again, let's list all of the givens for this problem. Here we go. A mare named Sheba. Now, a mare is a mommy horse. All right, it's a girl horse, probably has had a baby. All right, a mare named Sheba is running with a velocity of 2 meters per second south. Now, because it's 2 meters per second south, I'm going to put negative 2 meters per second. All right, over a distance of 20 meters. All right, she accelerates to a velocity of 5 meters per second south. Now, if she's heading south and she goes 20 meters south, that is a negative displacement. All right, because she's heading south and she accelerates south, so she's going south, 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 south. All right, you'll see as we get to read this complete problem, she is not changing her direction. Over a distance of 20 meters, she accelerates to a velocity of 5 meters per second south. All right, so her final velocity is 5 meters per second south. That's negative 5 meters per second. All right, now she wants to catch up to her little filly, Jessie. A filly is a little baby girl horse. A little baby boy horse is called a colt. All right, so Jessie is a little baby girl horse. She's called a filly. If Sheba had a little baby boy horse, it would be called a colt. All right, so she catches up to her baby. All right, now A, calculate the mare's acceleration. So one thing that we're trying to find is the acceleration. Meters per second squared. We are trying to find her acceleration. And then we want to know how long did it take. So we're also trying to find how many seconds it took her to do this. All right, so we're trying to find her acceleration, and we're trying to find the amount of time that it took. Now, I will say this. If a physics problem is designed well, then the first variable that they ask for will be the easier one to find. So generally speaking, you'd want to find the acceleration first and then the time. All right, if the problem isn't written terribly well, maybe you would find the time first, then go back and try to find the acceleration. But this problem is written correctly, and if they ask you for the acceleration first, that's going to be the easier variable to find, and then you would find the time. All right? Now, how long? All right. The rest of the questions here, when your initial velocity and acceleration have the same sign, all right, so if your initial velocity, all right, is negative, okay, and you continue to go negative, that means that your acceleration must have been negative. So what we have here, when your initial velocity and acceleration have the same sign, in other words, they're going in the same direction, you go faster. And we know that we're going faster because a velocity of negative 5 meters per second, all right, this one here, negative 5 meters per second, is faster than a velocity of negative 2 meters per second. Right? If you're going 5 meters in a negative direction, so you're going 5 meters south every second, so after 2 seconds you've gone 10 meters south, etc. If you're only going 2 meters per second south, so after 1 second you've gone 2 meters, after 2 seconds you've gone 4 meters south, clearly negative 5 meters per second is faster than negative 2 meters per second. All right, just keep that in mind. So what you want to do now, all right, what I'm going to do is I'm going to erase the questions, right, and I'm going to put the given over here so that we can start selecting equations and solving for A and B. The reason you make a list of givens is so that it can help you to select an appropriate equation to solve the problem. Now, here are the first 5 equations on page 6, the mechanics page of the physics reference tables. 1, right, 2 and 3 is actually the same equation, right, and then 4 and 5. Now, we're trying to find acceleration. So obviously, we're not going to select equation number 1. It doesn't even have acceleration. But there's another reason why we don't select equation number 1. All right, we don't know the time yet. And you would need the time to do anything much with this equation. So we're not going to select equation number 1. Now, equation number 2, we're trying to find acceleration. But again, we don't know the time. So there's 2 variables that we don't know. That's not a good equation to answer the question that we're trying to answer right now. Look at equation number 4. We're trying to find acceleration, but again, we do not know the time. So we've got 2 variables that we don't know. We're not going to pick that equation either. So far, we've ruled out this one. All right, this one is the same equation as that one, and we've ruled out this one. Now let's take a look at equation number 5. We're trying to find acceleration. There it is. We have the displacement, the initial velocity, and the final velocity. Look, we have the displacement, the initial velocity, and the final velocity. So there's only one thing here that we don't know. So this equation is the one we should be using to solve for the acceleration. All right, so let's take this equation, move it up, and solve for acceleration. Now, the other thing we need to do is get the A by itself on the left side. So we've got V final squared equals V initial squared plus 2AD. We're trying to get the A by itself. Let's subtract V initial squared from both sides. All right, so now we've got V final squared minus V initial squared equals 2AD. We want to get the A by itself. Divide by the 2 and the D, right? Divide by the 2 and the D. 2 and D cancel. So the equation that we will be using, A equals V final squared minus V initial squared over 2D. Okay, now we're ready to get started. All right, so there are some preliminary steps. All right, so the first equation that we will be using here, all right, A equals V final squared minus V initial squared all over 2 times D. Now, let me tell you something here. when a problem has only one direction, and we know there's only one direction because the horse started going south, ended going south, so we know that the acceleration must have been south, and of course the displacement was south. Everything was south, south, south. All right? As long as you're only going in one direction and you are not slowing down, this horse was speeding up, you don't have to put negatives into the equation. All right? So, we do not have to put negatives into the equation because there's one direction and we are not slowing down. So, here we go. V final. All right? Now, do not change the numbers. 5.00 must stay as 5.00. Inside the parentheses, 5.00 meters per second gets squared. If you put meters per second outside the parentheses, it will be marked wrong. If you put the squared inside the parentheses, it will be marked wrong. The math is wrong if you write it that way, so don't do that. All right, now, my initial velocity, 2.00, so 2.00 meters per second squared, right, all over 2 times the displacement, 20 meters, okay? So the acceleration is 5 squared is 25, 2 squared is 4, 25 minus 4 is 21 divided by 40. All right, so 21 divided by 40, okay, is 0.525. All right, and 0.525. Now, if we're going to use this acceleration later, we should take along one more significant figure. All right, actually just truncate it at 4. All right, so that's meters per second squared. Now, we have to report our answer as negative because we know that the acceleration was south. So our final answer is negative 0.525 meters per second squared. All right, we tacked on the 0 because we got exactly 0.525, and we will probably use the acceleration to find the time. If you're going to use the number later, you need one extra number, right there. If you want to report it as an answer, you round to 1, 2, 3, 1, 2, 3, 1, 2, 3 significant figures. 1, 2, 3 significant figures to the answer. All right, so our answer is negative 0.525, or you could say 0.525 meters per second squared south. Okay? Now we try to find the time. All right, how long did this take? All right, and for this, since we now have V initial, V final, and A, we can use our very simple equation. All right, that would be equation number 2. All right? And that would be A equals V final minus V initial divided by T. But we're trying to find time, so we're going to get time by itself. We can switch the inverses. A and T are inversely related. The T comes up here, the A goes down there. The equation we will be plugging into is T equals V final minus V initial over A. All right, so let's plug in. And again, because everything is negative, we do not have to put the negatives into the equation. All right, we get the same answer whether we put the negatives in or we don't, because everything is negative. All right, so V final, 5.00, V initial 2.00, V final 5.00 meters per second minus 2.00 meters per second. Don't put unnecessary parentheses if you don't need them. You need them here to square, you need it here because it's 2 times that, but you do not need parentheses here, so don't put them. All right, don't put any unnecessary marks that you don't need, that are not serving a purpose. All right, here, 0.5250 meters per second squared is the acceleration that we carried over from this part of the problem. All right, so we've got 3 divided by 0.525. 3 divided by 0.525. And we're getting 5.714 seconds. 5.714 seconds. So if we were going to use this number later, we would use the extra 4, but to report the answer, we report to 3 significant figures. 1, 2, 3, 1, 2, 3, 1, 2, 3. So our correct answer, time equals 5.71 seconds. All right, now, keep in mind, time, and while we're at it, mass, should never come out negative. If time comes out negative, there's a mistake somewhere in the math, right? Or you put the direction wrong or something like that. Time and mass must never come out negative. All right, so what you want to do now, go back to the spot in the video where the problem was blank and try it completely on your own from the beginning. See how you do. If you have any problems at all, then you're going to watch me do it one more time. One more time.